In this video, I'm going to discuss very briefly the patch table system and just how to read it and understand it and what it does. So in a CRO file, I will assume that you've looked at the documentation online and just seen like kind of this basic system. This is a honestly much better spreadsheet I made just so I could visualize it and kind of just paste in the header over here and just spit out like exactly where everything is. Um, so the relocation patch table location and size is located down here bytes from starting at bytes 0x128. So let's see, that would be right over here. So you see that we have a little endian, of course. So this is starting out 123B80 with 2028 entries. This is actually not the location that you'll see that as you can see this is a ultrasun ultramoon battle CR.CRO. This is actually not the location. It will be in a standard unedited one. I've already used my CRO expander to enlarge the code section. So this is actually displaced by, I believe, if I remember correctly, 4096 bytes. So if we just jump down to the beginning of that relocation patch table, you'll see I was already there. You'll see it starts right after this very long series of like mushed together text. Essentially, what these are doing up here, these are essentially for function calls in and out of this CRO to code.bin and to, I believe, the underlying like 3DS um, functions there. So some of those are like those are just that's I don't actually quite understand exactly how and what that's doing yet. That's future project. So the way the relocation patch table works is each entry in the table is just 12 bytes. Um, so I'm just going to copy this first one just so I can use it as an example. Just use over here. So this is 12 bytes. And essentially what the relocation patch table does is as follows. When a CRO is loaded by the 3DS, it only loads one CRO at a time. You have the code.bin file, which is the main code section. That's loaded at virtual memory offset 0x001, rest of zeros to fill the 8 digits. And then the game essentially hot swaps in whatever CRO it needs at that moment. The um, and essentially this very long patch table is essentially what it does is when the CRO loads, there's a whole bunch of functions and tables that it needs to look at whose locations are not necessarily fixed. They might move around. They might reference something that's outside of the actual CRO file that was just loaded in. I believe depending on the exact firmware and console, even the exact location the CRO is loaded might vary. So um, cases where there would be absolute references obviously wouldn't work. So this basically when it loads, it just this interfaces with the CR loader in the 3DS, and it kind of just writes all these addresses so it knows where everything should be. The way this works is that this is actually in 4 segments. I'm just going to break it up into these primary segments here. We have that. We have the next 4 bytes, and then the next 4 bytes. Okay, so now it's broken up into the 4 sections. Before I go into this, there's one more thing I need to mention, which is the segment table. I actually have an example pulled up in here. Essentially, yeah, segment table. So basically, the CRO is composed of a number of segments. The header starts at the very beginning over here, and runs all the way up until um, oh, but yeah, it's the first. It's this here that I just highlighted. That's a hash table that the game that an unmodded 3DS will use to make sure that everything is valid. Luma 3DS for a very long time, and obviously also Citra just ignore this, so you don't have to worry about that. This actually starts the header data that kind of tells the game what CRO this is. That is a CRO. The size of all of its parts. And also what CROs and then there's like other like references it has that you don't need to worry about. There's some blank segments that the game actually writes to when it loads for its own purposes that we also don't really need to worry about. But essentially, the CRO is formed of at most 4 sections. The first one starts here at OX180. Um, this for every CRO, it will have like you'll see that it'll have a bunch of like the same thing 04 or F0, 1FE5, and four zeros, and for larger zeros for quite some time. And after this, you'll have the actual bulk of the actual game code that's in the CRO. At the end of this, there's something called RO data, which has essentially depending on what the compiler decided and probably to some degree what Game Freak decided for any given thing, it will have some data tables. For example, in the shop.cro, the data tables for like what items are sold by what shops and for what price for Battle Point shops are actually in the RO data. Other than that, it mostly has things like the patch table and kind of a whole bunch of other information about the actual CRO itself to tell itself where everything is and to tell the rest of the other things where everything is. After that is the data section. This has a combination of basically all the rest of the tables that CRO needs. All kinds of data tables. Um, it This is different because this has write permission as well as read permission. So the anything here the game can overwrite and insert data into and so on and so forth. After that is the BSS section. That doesn't actually exist in the file CRL you're looking at because that's just basically just a regular RAM that it's allocated. So there's nothing that actually needs to like start out there. It just starts off with whatever the size is as a bunch of zeros, and it writes there to whatever location is needed. For example, in the battle.0, a lot of stuff about the state of the battle and like the Pokemon in your party and stuff are written to this section. Um, and what's important is each one of these sections has different read, write, and execute permissions. So if you are inserting code or data, if you try to like insert code into something that's not in this section, if you're on console, it will crash when it tries to run the code because it is not allowed to run code outside of this section. Citra does not care, so just be warned. Computer stop. So just be warned that if you are testing things on Citra, they very well might crash on console. Just be aware of that. Um, yeah. So anyway, this is important going back away from that tangent. This is important for this because these are not because when the game essentially when the CRO is loaded, these pieces don't all get loaded contiguously like they are in the actual file that you're editing. Text and RO data kind of get stuck together at a fixed place starting at least in the last firmware for the new 3DS at OX6DD000. I've used that number so many times in the last several weeks it's burned into my brain. These go together as they are in the file. That data gets thrown all the way very far away in memory in the heap where it's read write. Um, and BSS generally starts immediately after that data ends. It theoretically, I guess, could start somewhere else, but I don't think there's actually a way to make that happen because the start location is written when the CRO is loaded. So I guess something could make that load somewhere else, but as far as I know, it never does that. So essentially, what these do is these are not references to the exact address to an absolute address in memory. Instead, this is a distance away from the start of the segment that it's in. And as you can see, these segments are numbered 0 through 4. Um, so um, what these do is these are basically saying this essentially what this says in summary is go to a certain address, go to a certain offset in a starting from a certain segment, and then write and then figure out what absolute address is this offset after in some other segment and write that value there. And then when the code runs, it's able to look and figure out, okay, I need to go look at that address for this table, or I need to run this function located at whatever that pointer is. And it's a little bit more complicated than it might seem because um, these are encoded a little bit funnily to a little bit differently than you might think. So first of all, this byte here, byte number 4 we basically never need to worry about because there's a number of different ways the relocation patch can be. As far as I've seen, every single patch in Ultra Sun Ultra Moon uses is the 02, which is what I'm going to be explaining. If I ever find something else, I'll update this tutorial. But anyway, I'm going to actually start from the address that it writes to. This is the address of some function that it needs to know to call, or some table it needs to know to look up to. This one's actually a little bit simpler because all this is little endian. So this would just be 00000384. I know I don't need to write the zeros, but I'm just so used to typing them, so like everything gets aligned. And then you go, and then so this is the offset that it's writing to, and then it looks at byte 05. And that is the segment and that's the segment. So we would look, so we would look at, obviously so 03 is over here. So this would be so 03 would be in the BSS, the scratch pad. So it would be saying, okay, so it would be saying, okay, go to wherever the BSS segment offset starts, add that number to this, and then write that to the address specified by this block. So this is a little bit more complicated. You'll have to know a little bit about bit shift. So basically, I'm just gonna rewrite this in big endian because Excel does not know how to handle little endian. I probably should get around to writing a function to like deal with that, but I just haven't gotten around to it yet. So basically the way this works is that the lowest 4 bits, so which basically corresponds to the lowest, to the, once you turn it into big endian, to this, the lowest hex digit, that specifies the segment that you're writing to. So in this case, that's 0. So we would be like, okay, that's that's here, that's in the dot text section, which is where all the code is. So what you would need to do is, so in order to figure out where this is actually writing to, Excel does not know how to deal with hexadecimal, so I'm actually just going to call up my calculator, because that's going to be simpler than like typing in all those functions. So we have the number 3db00. We would do, in order to figure, obviously, like, the segments are only going to be 0, 1, 2, 3, or 4, so like you're just going to look at that lowest, digit. But for sake of completeness, bit and F, you see that's 0. And then to see the actual offset, 3db 00, we would want to bit shift 4, so you don't just move the whole number 4. It's the equivalent of like just chopping off the right 4 digits of a 10-digit number, same difference. So right shift 4 in this case is 3db0. So what this tells us, is that we would go to .code, which, where we're starting at, so we can actually look exactly where in the file this would be, because this would just be, OX180 plus this, unless they screwed something up royally. So you can see that would be 3F30. So if we go to 3F30 in this file, you'll see, okay, yeah, so you see there are these 4 blank digits here. So in the game, so when this 0 is loaded, it will go to this wherever this location is loaded in the game memory, and it will write this value plus wherever the BSS section starts here, and then this code over here will be able to look up, will be able to function with that. I'm actually just going to throw that into a hex converter. I'll just grab the big chunk before it, because that will hopefully actually get, all the code to be able to see what this is doing. I'm just gonna cut out, I'm just cutting out the, yeah, okay. Just gonna move this in here so we can see. And then R0, R4. Okay, yeah, see, because here it's here it's loading, yeah, okay, here and here it's loading the data that's written to these spots, and then it is okay, then it's loading the first one, and it's storing a value to a location based on that. It's loading the second one, and branching somewhere to do something else with it. So see, it's loading. It's getting these values that once they're loaded into memory, and doing something with them. That's basically all the patch table does. When it just it just uses this system to figure out exactly where to tell itself where bits of it were moved to when the game was loaded. I'll end this here. Hopefully that was followable for people, for anyone.